And get started. Good afternoon,
Okay.
everyone. Let me remind you who our speaker for next week is. It's going to be Professor William Hogan, who is the Raymond Planck Professor of Global Energy Policy at Harvard University. And Professor Hogan will talk to us about resource adequacy and in particular how to price peak electricity right. So he has some innovative ideas that have actually been implemented to some extent in the ERCOT market, and we just want to have some more discussion. It's a really, really important problem, and Professor Hogan is the leading figure globally in thinking about these issues. So please join us next week for Professor Hogan's talk. Actually, let me correct myself. It's actually not next week. It's 2 weeks from now because next week is spring break. Unless you want to join us next week here, it's actually 2 weeks from now. So with that, it gives me great pleasure to introduce to you our speaker today, Dr. Carrie Armel. Carrie is a research associate at Stanford's Precourt Energy Efficiency Center, where she investigates diverse ways in which an understanding of human behavior can lead to improvements in energy efficiency. She has really done very influential and important work in this area, and some of that we'll get to hear from her today. Carrie co-chairs the Behavior, Energy, and Climate Change Conference. It is the conference at the interface of energy and behavior, period. I really love going to that conference myself. I've been there in 2011, 2012. Last year I couldn't go, but I'm going there with a very large team actually this year in November, December. She also oversees the Precourt Institute's Behavior and Energy Bibliography Database and website, and she teaches courses on behavior and energy at Stanford. She has numerous and important publications. Just to give you an example, she has published in Nature Neuroscience, American Economic Review, just to give you some idea. She completed her PhD in cognitive neuroscience from University of California in San Diego, and has done 2 postdocs at Stanford, one in economics department, I believe from 2004 to 2006, and then from 6 to 8, she did another postdoc at the Stanford School of Medicine, and during these 3-4 years of her postdoc years, she was working on different aspects of neuroeconomics and bringing some of the concepts from health innovation into the energy arena. So with that, I will leave Carrie to talk about the $6 million effort that she brought to Stanford a couple years ago. Carrie, it's over to you now.
Great. Thank you so much for that nice introduction. Can you hear me okay?
Yes, perfect.
Okay. I'm going to hang up the phone now?
Yes.
Okay. Sounds good. Thanks. Okay. So if at any point we have any audio problems, please just speak up or call me back. But otherwise, I'll jump in and get started. So let's see. Before I jump into talking about our ARPA-E effort, I just want to make sure that we're on the same page when I talk about energy efficient actions or behaviors. So sometimes when I talk about 2 utilities, they think that I'm referring specifically to habits like turning off lights or television sets, etc. But really when I say energy efficient actions, I mean anything that we need to have people do in order to achieve energy savings. So that could be purchasing and installing energy efficient technologies, reducing waste, like unplugging extra fridges, shifting settings and installing controls, repairing items, performing maintenance, as well as adjusting patterns of use or habits. Okay, so our initiative attempts to address the following problems. First, that billions are being spent for a smart infrastructure. Smart meters, home area network, transportation, and other sensors are becoming pervasive. And yet, without full consideration of the human element, this infrastructure won't reach its full energy and cost savings potential. And the second problem is that energy efficiency is difficult. So figuring out what to do and how to do it is difficult and boring. Yet it's important because, for example, we know that U.S. energy from residential buildings, about 25% of U.S. energy comes from residential. residential buildings, about 20% from commercial buildings, et cetera, et cetera. So how can we address both of these issues? How can we leverage a smart infrastructure to maximize energy savings? So our solution was quantification, using quantification from sensors. So quantification can provide diagnostics and personalized recommendations so that people aren't left guessing what they should do. Second, quantification enables a variety of behavioral techniques that were difficult to implement before. For example, feedback, incentives, markets, competitions, data visualization, etc. And third, quantification allows us to create the best programs with improved speed, ease, cost, and scale through the objective evaluation of program energy savings. And in addition to that, in addition to evaluating programs and improving them because we have objective measures and results now, in addition to that benefit of quantification and measurement of program savings, also allows utilities to quantify their savings for public utility commissions so that they can be compensated for them. So it's an added benefit for utilities in the program evaluation space as well. Okay, so more specifically on our project, the primary goal of our sensor and energy behavior initiative is to leverage smart meter and other sensor data with behavioral approaches to achieve widespread energy savings. So we have about 20 different projects to that end, the pictures here are small, but you'll see a lot of these pictures blown up in the coming slides. So this is just to give a quick visual overview. Our team includes 15 faculty from 10 departments, ranging from computer science, electrical engineering, civil and environmental engineering, economics on the one hand, as well as mechanical engineering, design, etc. And on the other, we have psychology, communications, education, and behavioral epidemiology at the School of Medicine. So it's very interdisciplinary, and even within projects, we have fairly interdisciplinary teams. And to date, all of these projects have been run and evaluated separately, but the goal has been we specifically identified projects that spanned the range of projects that we felt, or work that we felt was needed in this space in order to leverage sensor data to achieve and use behavioral techniques to achieve energy savings. So we sort of got the breadth of projects that we felt we needed, and the goal now is to take some of the successful elements from the various projects and use them together into a more comprehensive single program. And at the end of the talk, I'll talk a little bit about where we're at with that. So we just got funding renewed for another 2 years to do that and attempt to scale out the program. Okay, so zooming into this overview conceptual diagram, this is an overview of all of our projects and how they fit together. So we have a unique opportunity at this point in history because on the left we have the wireless sensors, which are becoming pervasive, and at the right, for example, all of Texas, to my understanding, and as well as California in the investor-owned utility territories, all the houses and commercial buildings have smart meters at this point, et cetera. And on the right, we have web-enabled devices so that computers and phones can deliver programs at scale to help individuals reduce energy use. In the middle, we have Stanford's engine, which links the two. And in the engine, we have 3 buckets. So the first bucket is the technology platform and includes projects that use sensor data to perform analytics, like diagnostics on where a given individual should save energy. Or we also have a technology platform which supports data capture and storage, as well as the behavioral programs in that middle green bucket. And the middle green bucket are the programs, which I'll talk about several today. And then the third bucket includes modeling and evaluation. So here, quantification allows us to quantify the programs and improve them, like I mentioned before. Okay, so I'm going to jump into some of the projects now. I'll talk about a couple of projects in each of those three buckets. Okay, so starting on the technology bucket, I'm going to talk about some of the algorithmic work. So we have three projects that relate to disaggregation. So disaggregation is the taking of the whole home energy signal and using statistical approaches to separate that signal into appliance-specific information. And so that makes the energy data more actionable because people can then understand where they're using most of their energy, and they can try to make changes and see what the impact of those changes are, whether it reduces their energy use, et cetera. And then we can also, by identifying those, we can provide recommendations as to what people should do to reduce their energy use, et cetera. So the data becomes much more actionable. So we have three projects in this space. The first project, and before I forget, I should mention we recently have put up a website, which it was on one of my earlier slides, and I can share those slides as well as forward it on to the crowd. But we recently put up a website, and it has descriptions of all of the projects as well as all the publications that have come out of each of the projects, and we're currently also in process of putting up deliverables from the different projects. So a lot of the projects have software or something else associated with them that's shareable. So, so the first project in the disaggregation space was a review of what algorithms are available both in the academic literature as well as what companies are working in that space. An evaluation of, based on that overview, what different types of data afford in terms of, say, the number of appliances that we can disaggregate, so what frequency of data might we need, et cetera. And then we also did an assessment of smart meter technology to see what data the smart meters are able to provide and whether that would be adequate for the algorithms. And the reason why we specifically pursued smart meters is because we really were looking to how the disaggregation could be scaled in order to get widespread energy savings, and felt like additional hardware would be difficult to get widespread adoption on, whereas smart meters were already being installed pretty widely. So, that review paper is very comprehensive. That's currently posted online. There's associated talks, et cetera, posted online. The second disaggregation project that we did, we collected data from about 40 homes in both the Boston area as well as the San Francisco Bay Area, where we had 16 kilohertz data, whole home data, as well as circuit level and plug level data. At the circuit level is about a minute data resolution, and the plug level data was either 1 second or 1 minute, depending on the house. And so that data set is available, and the intent of that is to share it with algorithm developers as well, because there's not any good data sets that we were able to find currently out there, as well as to allow people to benchmark and develop standards and metrics, et cetera, for data sets. And just briefly, the third disaggregation project that we had was actually development of algorithms, and that work was done by Zico Colter, who was at Stanford but is now at CMU. And he used a sparse coding method to improve the number of appliances that could be disaggregated from hourly data. So I'm happy to talk more about disaggregation, but just in the interest of time, I'm going to move on at this point. So a second algorithm project that we had relates to segmentation. We got a data set of about 250,000 PG&E customers, both residential and commercial. And this project was led by Ram Rajagopal as well as Martin Fisher. And the initial purpose of the data set was to better segment and target the customer population so that programs could be better matched with the customers. So for example, you can see in these graphs energy usage over the course of a day, and some people are higher evening energy users. Not presented here, but in other graphs you can see some people would use energy data disproportionately on the weekends. They might stay at home during the day, et cetera. And by understanding these, how the population breaks out and who fits into each of the buckets, we can better target programs. So it's both more efficient use of marketing dollars as well as providing a better match for people, and when the match is better, people are more likely to engage in the program. And this approach is in contrast to utilities typically using demographic variables as well as marketing type traits of households, like the use of axiom variables, et cetera, but more traditional characterization based on traits rather than actual energy consumption. And following this work, they've also had a couple of additional spin-off projects with this data set where they've done disaggregation with hourly data, and they've also done heat profiling of buildings to better target folks that way. Okay, so that wraps up segmentation. I think I'm going to skip over the energy services platform. I mentioned just briefly that we developed some software to support the behavioral programs, and so this is just a description of what was developed, and we're writing documentation for this now in the hope of making the software available to other people should they want to more easily implement behavior change programs using sensor data. Okay, so moving on to the behavioral programs, we have 7 behavioral programs, and they break down into media programs, policy or incentive programs, and community-based programs. And we wanted to have a diversity of programs across these different types of interventions, drawing from a prominent public health model where if you have interventions of different types that are complementary, for example, if you're trying to get people to walk more and you create walking paths through a city, but you not only do that, but you promote walking clubs, which would be a community-based program, and then you market it, which would be a media program. All of those together have a synergistic effect that's more than the sum of its parts. And so we wanted to sort of do a buckshot, try out a few different programs, and then, like I said, hopefully pull some of the successful pieces across those to create a more comprehensive program that has these multiple types of interventions within them. So I'm going to jump into several of these and explain what we did. So one of our projects was called Powerdown. I should apologize for the Latin on here. I should update this with the final version of it. But the gist is that this is our very basic feedback interface. This is, I'd say, comparable to the type of thing that companies in the space have done, similar to O-Power type work where you have somewhat of you can see how much energy you're using, some comparison to others in the community, as well as recommendations. And this was deployed as an experiment. So all of our work, we both developed programs, we embedded experiments in them, and then we evaluated both the programs as well as manipulation. And this particular program, we looked at the effectiveness of framing information in different ways related to norming, and we also looked at tips. And we found that when the tips were presented in thematic clusters, so for example, all of the tips were related to heating, like a toaster oven, as well as heating your home, et cetera, so there were heating elements in it. So when there was a thematic tip as well as a community message, so they distinguished between whether the message was a comparison with your cohort, how much better or worse you're doing, versus a collaborative, community-based method, like we're all in this together. And they found that the collaborative, community-based message in combination with the thematic tips was the most powerful condition out of the various ones that were run. That was done. That was done in community Mountain View, California, with about 1,000 participants, and they had been recruited through a real energy saving program that was being run in the town. This was embedded as part of that program. The second project is an online game. So the previous one was headed up by Professor Greg Walton. This game is headed up by Professor Byron Reeves. It's called Powerhouse. It incorporates real-world energy data in some of the gameplay. So you can see a graph to the right. And so people can challenge, so they can pull in their Facebook friends, challenge them to Friday night lights out challenges and other things, and then you have the objective energy use data to compare how people did. But the idea is that there's also game modules that help people reduce their energy use. So in the background, you can see the game module that they've developed so far, where the family members run around the house and you help satisfy their needs by turning things on that they want to use, but also turning them off when they're no longer using them to reduce energy use. And you get points for both of those. The nice thing about the game is because the time is sped up in the game, people get a lot of quick practice turning things off, and the points are reinforcement for turning things off. So it quickly reinforces folks for getting in the habit of turning things off. We recently updated this game so that in the lower left corner is a real smart meter, and the energy consumed by the different appliances is accurate in order to take advantage of the learning opportunity here. Just a note on why an online game was pursued. As many as 400 million people worldwide operate avatars in virtual environments, so it seems like a good medium. And the population is also surprisingly diverse, given that gamers average 33 years old, and there's actually more of them in their 40s and 50s than in their teens. Just one last note in this, that the game has been tested in both a laboratory setting and in the real world. In the laboratory, individuals turned off appliances in the lab statistically significant more often, and in the real-world setting, they reduced energy consumption slightly during the period of gameplay, although it did go back up to baseline after the gameplay. And that was they played the game over a period of 10 weeks. Okay, let's see. And I should note that in the projects that are using energy consumption data, we're getting that from the platform that I described. So we built a scraper or a web collector to pull the energy data from utilities if folks signed up with us for that service. Now there's green button that's used both in Texas and California, and so the data can be gotten through that as well. Okay, so moving on, a third one of our interventions is through Change Labs. Danny Banerjee is a faculty who heads this up. He developed 3 Facebook apps. One of them is called, each of the Facebook apps was developed to sort of target or motivate people of 3 different decision-making styles. And those decision-making styles are dominated more by emotion, by social cues, as well as cognitive. So I'm not the cognitive interface I'm not showing here. That's more straightforward. It's just graphs of your energy use, etc. The emotional interface is Kadogo on the left. And the premise behind that is that your financial savings corresponding to your energy savings are tracked, and then you can donate those financial savings to individuals in developing countries. And the sort of behavioral economic premise behind this is that when you're microfinancing people, you're sort of stretching the value of the incentive because the dollar value associated with energy savings in the U.S. is relatively small, but that same amount of money microfinancing can go a lot farther in a developing country. And then on the right we have Power Tower, which is the social Facebook app. And in this one you get Tetris-like blocks based on how much energy you've saved, and then you have a team, and multiple people get those blocks, and you collaborate to build a tower based on that, and you compete against other groups that are doing the same thing. Just to check on audio, is everything going well still?
Yes.
Should I take that as a yes? I'm sorry, I don't hear anything. Okay, great. All right, super. Okay, so next. Oh. Hello?
Yes, audio is doing very well.
Okay. Okay. So next up we have InSink. InSink is headed by Professor Balaji Pavakar, and this program is a lottery type program. So this has been tried in Bangalore, India, and has been scaled out there. It's also, as part of our ARPA-E award, has been tried in Singapore and has now been scaled out there, and Balaji's also trying it on Stanford campus. In addition to so for the 3 of those, he's done transportation settings, and he's also done it in health settings and also for recycling. We did try to get a utility pilot going for electricity use, but that was more difficult than we had anticipated due to collaboration type issues, and I'm happy to go into that more if folks have questions on that. So the idea primarily is to give people points based on whether they shift off-peak, so certain number of points if they shift 1 hour off-peak, and more if they shift 2 hours off-peak. Also the same, and you can see how that time shifting can apply in the electricity domain. Like I said, this was done in the transportation domain. And also points if they switch to public transit rather than private transit. And then those points are entered into a lottery-like game. It's a little more complicated than that, but just in the interest of time, I won't go into the details. So Balaji was able to get about 20,000 people to sign up in the first 6 months of the program in Singapore, and they showed a 10% shifting of trips from peak to off-peak times, as well as significant mode shifting from private to public transit. Okay, the next project is our Appliance Calculator. Officially, that was headed up by Professor Sam McClure. And this calculator is accessible through Google Ads. In about a year, duration, we had about 60,000 online shoppers use the Appliance Calculator, and we've run several experiments embedded in the calculator as well. So the calculator allows you to enter in some information about your current refrigerator and compute the likely energy savings as well as cost for running that refrigerator, as well as input desired attributes of a new refrigerator. And we can search for any refrigerator that's currently on the market. And then comparisons can be done at the bottom. So for example, in one of our manipulations, we projected out the the cost savings over time if someone purchased the particular refrigerator that was recommended at the bottom versus using their current refrigerator and how much that would save them over different periods of time. So the interesting finding here is that first, the research group thought that by addressing the first cost bias that we would get the greatest energy savings. That is to say, it's believed that the reason why people don't buy energy-efficient appliances is because they pay the most attention to the upfront cost of the appliance rather than the potential energy savings they could get over the course of the life of the appliance. And so we thought by projecting out that savings over several years and showing them, we may be able to counter that bias and get them to purchase more energy efficient refrigerators. Interestingly, there ended up being no effect when we projected that out, but in other manipulations, when we simply used some very effective behavioral econ techniques, we did get savings. In fact, we got 10 to 20%. We got people to click through to refrigerators that were 10 to 20% more energy efficient. And for example, one of those manipulations was simply changing the sort order of the appliances in the search results box so that the default appliances that came up at the top were the most energy efficient. So it's an interesting take-home that sometimes we can analyze why a problem's occurring and try to address that problem, but it may be that simply taking some of the most effective techniques from other domains and applying them could end up resulting in just as large or even larger energy savings than taking the more analytical approach. Okay, and to move on to our last intervention that I'll cover today, this is our Girl Scout program. And Professors Tom Robinson and Nicole Ardoin lead the Community Girl Scout project. So we chose the Girl Scouts because they have high penetration. So the Girl Scouts organization tells us that 1 in 2 women in the U.S. either have been or currently are a Girl Scout. And I'm sure just based on previously asking this question at other talks, the proportion of people that tend to buy Girl Scout cookies is usually between 30 and 100% of the folks in the rooms when I ask. So the Girl Scouts are also a very nice organization to work with. They have great top-down organization. They're very efficient. So it was a good diffusion channel. We know that community-based programs can be very effective because there's word of mouth and there's people like me. It's more effective in creating norms and communities, et cetera. So they can get very high penetration rates, some of the highest penetration rates I've seen in behavioral energy behavior change studies have been community-based programs. So we developed we developed 2 curricula, actually. You can see the 2 represented here in the badges that we developed. So the bottom one represents the home electricity and gas use, and the top batch represents the energy-based transportation and food-related energy use. Those were two separate curriculums. Each of those had 5 sessions that we developed, and we tested the programs in 30 troops. So 15 troops received one intervention, 15 troops received the other. And we found significant changes in energy consuming behaviors, both for the girls as well as for their parents in the household. That's based on self-report. We're currently still analyzing the electricity and gas use data. The only other thing I want to say about the Girl Scout project is related to diffusion. So the intent wasn't entirely to get the energy savings through the Girl Scout program itself, but rather to use that as an initial point of contact to pull people into other programs. So we had the Girl Scouts, as part of the program, would create videos where they were newscasters and they were telling adults, like their parents, what they should do to save energy use, and then posted these videos online for the parents to see. And the videos were posted online at this website where there were other actions that the parents could take as well. And so the idea is that the girls would encourage their parents to go to the site to see their videos, and then the parents could take additional actions. Okay, so that wraps up the behavior change project. And I'm just going to do one, you know what, I'll just say a couple of words about this, and then I wanted to do a really quick demo of the integrative project that we're doing. So this is one of our evaluation projects, and this is called Twitter Explorer. It's a piece of software that was developed by some of our research here, Martha Russell being one of them. And basically, we could filter through all of the tweets that occurred in a designated period of time for words related to energy. And then once we collected those, we could analyze them based on content and semantic analyses, et cetera, to see how the conversation about energy changed over that time period, and also to track who the, or what type of diffusion was going on, and who were the high communicators about this. Okay, so that wraps up our existing projects, and I mentioned that we are integrating pieces of these projects. So 4 of the existing projects that I talked about are going to be funded to try to scale them. But a 5th project is integrating pieces of, more successful pieces of the project to try to create a comprehensive program. And we played around a little bit with what that might look like. And so what I want to show you is a first prototype of what that might look like. So I'm going to escape out and bring up my okay, so this is the Energy Whisperer program. We specifically did, we were aiming for a type of media that was kind of like Pixar, hoping that it would appeal to both children who could loop their families in and do some of the actions on their own, as well as to adults. So I'm not sure if we hit that, but that was the intent. And we were riffing off of the horse whisperer or the dog whisperer. And instead of Cesar Millan in the dog whisperer, we have Sergio Outleta with his sidekick Thermi over here. And instead of coming to your house in a reality TV show like Cesar Millan does, Sergio Outleta comes to your house through his episodes. So instead of episodes, they're episodes because they're mini apps, and each app targets a specific end-use behavior, like lighting or heating or whatever. And the idea is really to get people to execute the action. So each episode walks you through the steps needed to execute the action to reducing energy use in that domain or that end use, and helps to overcome your barriers in that area as much as possible. So if you need to buy something, then we'll pre-populate an Amazon order form or whatever. So the idea is to have multiple episodes, and we'll also have another page that has a dashboard with a feedback interface, smart meter data, and potentially disaggregation for folks who have sufficient data to do that, as well as some social networking abilities, as well as potentially an incentive there as well. We're working on the incentive right now. We're trying to link the energy efficiency to solar through an incentive design. But anyhow, that's a very quick overview, and I'm going to play the trailer now so that you can just get a feeling for what we made. The trailer was produced in collaboration with us. It was produced by Free Range Studios, who has also done The Story of Stuff, as well as The Meatrix and The Grocery Store Wars. So those have all been viral videos you could check out online. Let me know. Presumably the audio should work fine, given that you're hearing it through my computer. But if there's any issues, feel free to give me a call or stop me. So my apologies, I think I didn't have the audio on for the very first part of it, but hopefully you got enough of a gist from that. All right, so let's see, back to here. I think this was just an overview slide showing the framework for how we decided to design the Energy Whisperer, or we may reskin it, and but it would still have the general framework with the episodes. But in the interest of time, I won't go into that. And just to wrap up, I'd like to thank all of our amazing team. We have lots of faculty, other investigators, postdocs, graduate students, undergraduate students, partners who I attempted to mention throughout the course of the talk, but I'm sure I left some off. But just really an amazing group of people. And I'm happy to take any questions. Hi.
Hey, Carrie, this is Varun. This is just to prove that we have a lot of folks in the audience.
Okay.
And what I'm going to do here now, ask my TA Carson Sones to actually pass around both the microphone as well as my cell phone to whosoever has a question. All right? So
okay. And
go ahead, Carrie.
And I'll respond back through my computer, right, not through my phone? Is that right?
Yes, that's correct.
Okay, great. Okay.
But keep your cell phone on.
Yes, I will. Yep.
All right,
Thanks.
so we have several questions in the audience. Carson.
Hello? Hello?
Yes.
Hi.
Hi.
Thank you very much for the talk. Very, very interesting. So I was wondering that all these interventions looks very very good, but I was wondering, like in the long term, if you see that it will be necessary to keep with more intervention, or you see that this will provoke kind of long-term behavioral change, and it will propagate through different people. Oh, I am saving energy, then my friend also start to saving energy. So how you see the future of this type of the result of these interventions? Thanks.
Okay. Okay, so let me know if this way of answering the questions works, or we should modify it.
Okay.
The question was, I think, what is the longer-term plans for how we get diffusion and propagate the energy savings? And are these interventions really just sort of get things started, and then people will do it through community channels, or how will that work? And the way that we're currently conceiving of it, and it doesn't necessarily have to be this way, but this is the direction that I'm headed, and feel free to I always love hearing feedback, so if you have any criticisms or comments or anything, feel free to share. So the integrated project, the hope is to pull in the most effective pieces from the different interventions and to try to widely disseminate that. Can you hear okay?
Yes, we can hear you just fine.
Okay. And the intent is to propagate that in several ways. So one would be we got the Girl Scout program, and again,
You're getting quieter.
From Girl Scout program, this online system, the viral videos, given that
your audio is going in and out, I'm afraid.
That would be another approach. A third approach would be to have use Google Ads again, given we've had some success from that. Another approach would be I'm sorry, I'm checking on the audio. If Krista, if it's not coming through, type me a note again. Let's see, where was I? So another approach would be, the applets themselves can be embedded in other people's sites. So if many utilities or people blogging about energy use, et cetera, embed the applets in those sites, and people use an individual applet and see it there, we would have a link back to our central system so that people could get channeled in that way. So the idea is that we would get quite a number of people using the system through these diffusion channels. Whether we actually will or not has yet to be seen. Obviously, it's pretty hard to get large-scale penetration for things in the current media environment because there's so much competition, so we'd have to see about that. But the goal of the ARPA-E extended funding is to scale out the program as much as possible. That's really the intent of this next round of funding, to produce something that can be scaled out, that's commercially viable, and scale it out. So we'll see how that goes. So let me know if that answered your question or if you have other questions.
Can you hear me on this end? All right?
Yes.
Okay. Your audio, for some reason, went in and out a little bit in the middle, but it started strong and it ended strong. So whatever you did, that was...
Okay, I'll try to talk more directly.
We have another question for you.
Hi, thanks, Carrie. My question for you is, to what degree have you partnered with utilities to deploy some of this, or at least experiment with some of this in kind of a real world setting? And I know that you've done a number of behavioral studies, but have you actually tried to deploy any of this?
Okay, so this last question is, have we worked with any utilities as well as have we deployed any of the programs. So I guess for the second part of the question, whether we've deployed it, I think that depends on your definition. So I mentioned a couple of the programs, for example, had one in 1 year's time had about 60,000 participants, another about 20,000 participants. The Girl Scouts program, after running the trial, we did deploy it to Northern California Girl Scouts, so all of them have access to the boxes in the curriculum that was created, and that was sort of advertised through the troops. But I would consider all of those to be fairly small-scale dissemination efforts, and they were really done as pilots, as proof of concepts, and to verify that we could get energy savings, et cetera. The InSink program has been rolled out, so past the 20,000 people, that has been rolled out, I believe, to all of Singapore. I'd have to check on that. I could be wrong, but I know that it was definitely scaled out past the original size to a much larger area, and the same thing when they did the program in Bangalore. It was scaled out to a much larger area, and there's actually a real official program that is now supported entirely independently of Stanford. So there are cases in our projects where we've done that, but like I said, the intent to date really has been pilots of different scale as proof of concept so that we then can move to the next stage. This next round of funding for several of the projects like the online game and the Facebook apps and the Girl Scout project and ROM's algorithms, as well as the Energy Whisperer, the intent is now to polish them up and scale them out, for real as independent viable programs. The question about utilities is a really good one. So,
yeah, and that was,
so we have collaborated with utilities
can you hear me?
In various ways. So, for example, we got that data set from PG&E where we had, I think, 250,000 records that we analyzed, et cetera. We've talked to quite a number of utilities, all the California IOUs, several of the munis, Bonneville Power Administration, as well as utilities in other parts of the country. But it's actually been very difficult to get an active trial going with the utilities. And I think there's a number of reasons why that's been the case. And the tide may be changing. I think smart meter data is now more stable, whereas when we were pursuing it before, I think the utilities weren't quite ready. I think the programs now that we have pilot data as demonstration, I think, and we're cleaning the systems up so that they're more commercial grade. I think the utilities would also be more receptive. But we also found that the utilities are so slow, and it requires so much effort to work with them, and not having a real commercial organization where we have a whole arm of our organization that can deal with those interactions. It was actually quite difficult from that perspective to deal with utilities. And so I think we're looking more to partnering now with organizations that they themselves partner with utilities so that they already have established those relationships, et cetera. So I think I thought there was something else I was going to say, but I can't remember, and I think that's a good summary. Okay.
Hi, Carrie. Thanks. Oh, here we go. Thank you for the talk.
Sure.
You, one of the applications that I was most interested was kind of the one we spoke the least about, which was Twitter. Would you mind going into a little further about how you analyze the relationships? Is it just amount of retweets, or and kind of what specific words are being studied, or what the genesis is of each tweet? Just go a little further into that for me. Thank you.
Sure. So the question was whether I could go into a little more detail on Twitter Explorer. and I'll try my best. This is one of the projects that I know a bit less about, but we do have on the website that I mentioned, we do currently have online a summary of the project as well as a book chapter that was produced by them, and I'm working on getting in touch with the researcher to see whether we can actually post the software. But what we did for the particular study that they performed was over the course of, I believe, a year, it may have been longer, maybe a year and a half, we filtered out all of the tweets that occurred during that time period. And we filtered them based on about 150 energy and climate related keywords. So we came up with a list of those keywords, filtered them out. The database collected the tweets that had those words in it. And then there were several different types of analyses that were applied. I know that content analysis was one, semantic analysis was another, but there were several others, and there were also tracking of communication nodes as well. So I apologize that I probably don't know much more than that to answer your question. Originally, the software, the intent of the software was the idea, perhaps a bit of a fantasy at the time, was that our programs by the end of our grant would be so widespread that we would be able to track over the course of our grant how the energy conversation had changed over time based on our programs being deployed. But it was took so long to actually get the data, which we initially pursued working with utilities, et cetera, like I said in the last question. And that took so long, and we weren't able to get data from utilities, that then we had to build the web collector to collect the data. And by the time all of that happened, we collected the data, that we didn't get as many participants as we had originally envisioned with the large-scale rollout. I do remember what I was going to say in response to the end of the last question was just a contrast between utilities and other organizations. So we did have a study that we did with Google, and when they had their power meter out, and we, so to get the PG&E data set that was a static data set, so that wasn't live, but just the static data set, took us over 3 years of back and forth with them to get that data set. Whereas with Google, literally in 3 months' time, we actually had a live trial deployed, and we're collecting data from it, and we're able to start analyzing it 3 months after the trial was deployed. So the organizations can really have some very different institutional cultures, and as a result, a different ease and timeline as far as working with them. So that's it. Okay.
Hey, Carrie, we are almost towards the end of it, but I'll ask the final question, and it actually ties back to the first question that was asked. Probably part of it got lost in the translation, and the question was about persistence. So the programs are being deployed, and there is a significant change in several of them, and what about persistence, and what have you done, or what some of these projects have done about exploring the question of persistence, how long these behaviors persist, and which ones may be more effective in leading that type of longer-term change?
Sure. Okay, so question about persistence, extremely important question. So let's see, a few answers to this one. One, my very first slide talked about different types of actions that people could take to reduce energy use. So my ultimate goal is to reduce energy use. And if we can have people take one-time actions, and then the technology does the rest in maintaining the energy savings, that is great. That's wonderful, because it's fairly difficult to change habits if you want people to do repeat behaviors. So, for example, in the integrative project with those episodes at the bottom, where we can have the action be a one-time thing that we walk them through and have them do, and then the technology takes over there, that's fine with me. I think that's a great approach. A second answer is that we have not explicitly studied persistence. I would say in both the online game and the Google Power Meter project that we did, we looked a little bit at persistence, not a lot. And in both of those cases, the energy savings returned close to baseline after a short time period. So under those two scenarios, persistence doesn't look too good under these behavioral programs. But a couple of qualifications on that. So EPRI did a review of about 50 feedback studies that have been published in the last few decades, and there were, I think, about 12 studies that specifically looked at persistence, and they looked at persistence over a couple of year period. And for those, I think it was 9 out of the 11 studies actually did show persistence. And I could send a link to that report. We've linked to it on our website. And Jen Robinson and her collaborator have a nice table in the appendix where they list all the studies and provide details on all those studies, so you can see what might have been factors. But just to sort of cut to the chase of one of them, persistence also was studied recently by Hunt Alcott and related to O-Power trials, and so over many hundreds of thousands of people. And what they found is that if people receive the program in month 1, that over the course of the few weeks after they received the mailer, comparing them to their neighbors, their energy use would go back up very close to where it was before they received their mailer. But if they then received the mailer month 2, their use would go down after receiving the mailer, and it would slowly climb back up again, but it would climb up less than it had after the first mailer, and so on over the months. And I don't remember exactly what month it was, but roughly probably about after 1 year, so they would have received about 10 of the reports. My recollection is that the savings at that point were maintained close to what they were right after somebody receives the mailer, so they didn't climb back up to the baseline periods. So that's one approach to maintaining that persistence. So. Yep.
Yeah, our cell phones got disconnected. So thank you so much, Carrie. This was really great. The technology worked fine, and we are so glad that you were able to do this here with us. Thank you so much. Let's thank Carrie again.
Thank you. Thank you. That was great. If anybody has any questions, feel free to email me, and I'll also send along my the website address so that people can delve into the project further if they're interested. Thanks again for having me.
Yeah,
I
and
enjoyed
if
it.
you could also send me the slides, I'll share that with the class and the audience.
What was that? I'm sorry.
The slides.
Oh,
okay.
sure. I'll send that along. I can send along an annotated version of the slides themselves either way.
Okay, sounds great. Thank you so much, Carrie. Bye-bye.
Great. Thank you. Bye-bye.